All right, so let's go ahead and start looking at some applications with these right triangles. So the first thing I want to show you guys is this idea of angle of elevation versus angle of depression. Okay, so let me draw you a little diagram here to help explain what this is. Okay, so let me make that dotted. Okay, so first of all, if we're talking about angle of elevation, what this is essentially just the angle from the ground level up to whatever you're looking at. So say you happen to be looking at maybe some sort of balloon that's up here in the sky, okay? So the angle between the ground or between the horizontal and whatever you're looking at, this angle right here is your angle of elevation. Okay, so from the ground up is the angle of elevation. Okay. Now, on the other hand, if we're thinking about angle of depression, that would be, again, draw you a little diagram here. Okay. Okay, so this time, say you're hanging out up here looking down, and now your balloon has fallen down to the ground. So you're standing up above, looking down at something. The angle of depression would be this angle right here. Again, between the horizontal and whatever you're looking at down below. So angle of elevation, you're looking up at something. Angle of depression, you're looking down at something. So this right here is the angle of depression. Okay, now one thing that's interesting with these is that these are actually the same angle. Okay, if you were to do the geometry on this shape right here, the angle of depression is the same angle as the angle of elevation. It's just a matter of what your perspective is. So if you're low looking high, you're going to be talking about an angle of elevation. If you're up high looking down low, you're going to be talking about an angle of depression. But these angles are the same as one another, okay? So this fact right here, that these are equivalent angles, is going to be helpful information as we go through some different examples. Okay, so let's go ahead and take a look at a few examples. All right, so example 3 here says, from a boat on a lake, the angle of elevation to the top of a cliff is 21.2 degrees. If the base of the cliff is 1,373 73 feet from the boat, how high is the cliff? Okay, so I don't know about you guys, but I am very much a visual person. So I like to draw little diagrams just to sort of understand a little bit better what I'm looking at. I am certainly no artist, but I try. Okay. All right, so said we have a boat on a lake. So let's say I have a little rowboat. Little rowboat. Beautiful. Okay, hanging out on a lake. And then we have the angle of elevation up to the top of a cliff is 21.2 degrees. So let's say I have a cliff over here. There's my little cliff. Okay. And I have the angle of elevation up to the top of the cliff. So this angle right here, and make it a different color. So this angle right here is my angle of elevation is 21.2 degrees. Okay. All right, then it also tells us that the base of the cliff is 1,373 feet from the boat, okay, which means this distance right here from the boat to the base of the cliff is 1,373 feet. All right, and what we want to find is how high is the cliff. So we are looking for this height. I'm going to go ahead and just call it x. Okay. All right, so this is where our trig functions come in. Okay, so if we're thinking about this angle theta right here, we have our adjacent side. We want the opposite side. So if we think about what trig function relates the opposite and the adjacent side, well, that's our tangent function. Okay, so we would have the tangent of 21.2 degrees is equal to x divided by 1373. And then just solving for x, just multiply that 1,373 over. And then that we're just going to plug into our calculators. So if you pull out your calculator, where'd my calculator go? All right, so pull out your calculator. Make sure you're in degree mode. And I'm just going to plug in 1,373 times the tangent of 21.2 degrees. Enter. All right, so we get the height of our cliff then is approximately 532.552 feet high. Okay, so that would be our answer. All right, so this is the type of thing that we're going to be looking at in this section, using what we know about our trig functions, our trig ratios, primarily the sine, cosine, and tangent. Okay, and the reason we're going to focus on those three, the sine, cosine, and tangent, and not use the secant, cosecant, or cotangent are simply for the fact that our calculator has buttons for those. Okay, the calculator has a button for sine, cosine, tangent, but not for the three reciprocal functions. So it's just easier to use those three as opposed to the others. Okay. All right, let's go ahead and take a look at example 4 as well. All right, so this one says, from a balloon 721 feet high, the angle of depression to the ranger headquarters is 64.1 degrees. We want to know how far is the headquarters from a point on the ground directly below the balloon. Okay. All right, so I'm going to picture this as a hot air balloon. I don't know if that's what we're looking at, but that's what I'm seeing in my head. So we have a little hot air balloon. Lovely. Okay. Up in the sky. And then we have a little ranger station down on the ground. It's my ground level right here. A little ranger station. Cool. Okay. Like I said, I like to see a picture, but I am certainly not an artist. All right, so our balloon is 721 feet high. Okay, so this is 721 feet high. So this distance right here is 721. All right. It also tells us that the angle of depression to the ranger headquarters is 64.1 degrees. So remember, angle of depression is the angle measured from the horizontal line of sight down to whatever you're looking at on the ground. So here I'm thinking, well, this would be my horizontal line. And we're looking down at our ranger station down here. So my angle of depression is this angle right here from the horizontal line down. And that was given as 64.1 degrees. Okay. Now remember I told you a minute ago though that the angle of depression has the same measure as the angle of elevation. So from our perspective up in the balloon, we're looking down at the ranger station, we have this angle of depression of 64.1 degrees. But if you were a person standing down here at the ranger station looking up at the balloon, you would have your angle of elevation as that same angle, 64.1 degrees. So the reason I point this out is because we can use this to help solve our problem. So this angle down here is also 64.1 degrees. And that's going to be a little bit more useful because it falls within this triangle that we're looking at. Okay. All right. So what we're trying to find is how far is the headquarters from a point on the ground directly below the balloon. So if we think this is a point on the ground directly below our balloon, we're looking to find how far is that point on the ground to the ranger station. I'm going to go ahead and just call that X. All right, so now we just need to solve it. Okay, so let's think about what we have here. We have our 64.1 degrees. The 721 would be the opposite side, and X would be our adjacent side. So again, this is going to be using a tangent function. So we would have the tangent of 64.1 degrees is equal to opposite over adjacent. And then if we just solve this for X, we would have X is equal to 721 divided by the tangent of 64.1 degrees. Okay. Plug that into your calculator. So 721 divided by the tangent of 64.1 degrees. And I know I'm still in degree mode because I haven't changed it. So we have about 350.099 if we round 3 decimal places. Okay. All right, so that is going to be our final answer.